In today's video, we're going to take a look at how to replace a substring inside a string in C. Now, since the standard library doesn't actually have anything implemented in it, we're going to have to implement our own function. I'm going to show you how to do so and how to sort of optimize that function so that it's a really good one that you can use in any project. So let's start from what we have to do really. Let's start with just a string. So I'm going to say char str. I'm going to say the apples are delicious. Right? Period. I'm going to printf this string. So %s\n str. And what I want is really replace this apples word with, let's say, hamburgers or something. So what I want is a function called string_replace that takes in our str, takes in the word apples and the word hamburgers. And all it does is simply replace only the first occurrence of this word apples from inside the string and replaces it with hamburgers. So this function doesn't exist, so we're gonna have to actually write it ourselves. But before I forget, let's also printf the result. Like after this function that we're gonna create is called, we're gonna printf to see the difference. So let's start. I'm gonna not return anything for now. Call it string replace, and this guy's gonna take 3 parameters. First is our source, so this is the main string. Then is our substring that we want to search for, right? Our apples here. And then the word, or the string that we want to replace that substring with. That's how I'm gonna call it. Because then if you read the actual signature, it says string replace, and then this is with. It's pretty obvious that that's what you're gonna replace with. But before we actually get into implementing the actual code, we should think about what we need to do, because the task at hand is not quite simple. I want to give you an overview of how to do this. First, the first step is actually pretty easy. What we have to do is just find the substring that we want to search for in our string. Which I'm gonna note the pointers with, let's say, with green, which is here, right? And we're gonna get a pointer that points to this A here. That's the first step. Okay. Then what we need to do is replace the string here, but not quite, because if we replace it character by character, you'll notice that our other word that we want to replace with, the hamburgers word, is actually much larger than our apples substring. So before doing that, we're gonna have to move whatever is after this. So whatever is after this guy, I'm gonna note it with, let's say, red. Whatever is after this substring, either to the right or to the left, depending on whether or not the word that we want to replace with is larger or smaller. Now you notice here I also added the null terminator, just so that we don't forget about it. It's always there in any string that you're gonna work with, and you should not forget about it. And here is actually very, very important you don't forget about it. You'll see when we get to implementing it. So we need to move these characters. Well, first we should know how many are in here. Well, I'm gonna name this guy, so let me get here a number or an actual name here. Let's say P. Now this P is pointing to the start of our substring in the string, in the bigger string here. And well, what's the size of our string that we need to move? Well, the answer is quite simple actually. What we can do is just call strlen on our pointer here and get the size of this whole thing, and then simply subtract the size of the substring here. Okay? Because really all we need to move is everything except the substring from here onwards. We don't care what happens with this the word. So the size that we need to actually move is strlen of p minus, I'm gonna go down here, strlen of our substring, so of our apples here, just the word apples, and then plus 1. Plus 1 because we really need to move, like strlen doesn't take into consideration the null terminator. So even though strlen does give us the length of the string, it omits the null terminator, but we need to take that into consideration when moving the string around. Okay? So that's why we add 1 here. So this is the size of our red portion here. Nice. Now all we need to do is really move it. Move it to the right or to the left. So I wrote here the result that we should actually get after calling this function. And you might notice that the part after our substring here, right, the hamburgers, the space here, and are delicious, has been moved to the right. That's to be expected. But how many characters exactly? Well, you might notice that hamburgers has how many characters? Like 5, 10 characters, and apples has 6. And it actually moved this many characters, which is 4 characters. So this black portion here that I've highlighted is actually the number of characters we have to move this red part. How many characters is that? Well, that's simply the size of our string that we want to replace with, so our hamburgers word here, minus the size of our substring, right? So that's basically 10 minus 6. And this is what we get. So this is how much we need to move it, either to the right or to the left. Notice that if substring was larger than the with string here, the number would be negative. And that would be fine. That would just mean that we have to move it to the left. And of course, after we've moved this red portion either to the right or to the left, then we can simply replace or just str copy our with on top of our p here, right? Because now there is guaranteed to be enough space inside that area that we can fit that word in. So with all this in mind, we're gonna come back to this probably. Let's start implementing the actual function here. So back here, we have the source and we have the substring. First, what we need to do is just find the substring, so this guy, inside our source. I'm gonna say str. This is the function that searches strings or substrings inside strings. I want to search inside our source the substring. Okay, and this guy returns a pointer to that, which is great. Instead of p, as I called it there, just for it being much shorter, I'm going to call it actually substring underscore source. That's because this is the substring inside our source here. So this is where the substring, you can find the substring that we're searching for inside our source string. Now, if this guy is null, if substring is null, or substring source is null, then we know that nothing was found. So no word that we can replace with. So we can simply just return out of it. So just return and we're done. The word apples was not found inside our string. But of course, if it is found, we have to do that operation. Now you might remember that I made a video about memmove and the difference between it and strcopy or memcopy. The memmove in all implementations of any compiler is guaranteed to actually work with overlapping source and destination. Right now, this is what we're trying to do, right? We want to really copy this part to the right of the same string, same exact string, right? So here to here, but they are actually the same string in memory. This is dangerous with many functions, but memmove is really the only one in the standard library that allows you to do so. So this is why we're going to use memmove and not strcopy to actually copy it. So memmove, right? Memmove needs first a destination. So where do we want to copy? Well, where do we want to copy? Well, we have that already, right? We need, so we want to copy over to here, which was what exactly? Well, this guy is actually this pointer plus the size of the with string. So we can simply copy it over there. So let's do that. And say substring source plus the strlen of our with character. So this is where we want to copy things into. Then we need to know from where we want to copy things. Well, we want to copy things after this substring source. So this is where that apple word starts, but right after it. Well, after that substring is just the substring source plus the substring length, right? That should be expected. So then what we have to do is just say substring source plus strlen of substring here. Okay, and then the last parameter of memmove is the size. So how many characters we need to copy, and that's something that we have calculated here, right? It is strlen of the string from here minus the substring itself that we want to replace, and plus 1 because we're using memmove. Okay, so strlen of substring source minus strlen of substring plus 1, and this is the end of the call. Plus 1 because we're not using strcopy. With strcopy we wouldn't have to use plus 1 or strncopy really, but since we're using memmove, this guy doesn't know about strings, so we need to tell it to actually copy the null terminator that is at the end of the string. Never forget about that. Okay, so this is the movement operation, right? We have moved this part from here all the way to here, right? Let me highlight it. So we have moved it. Now, well, in here there's still just apples with a lot of probably garbage data. Okay, so we need to actually replace the word itself. For this, we should actually use memcopy. So let's say memcopy, and I want to copy where exactly? Well, where the substring is inside the source. So substring underscore source. That's where I want to copy. What do I want to copy? Well, I want to copy the word that we want to replace with. So our with string. And then how many characters? Well, it's of course strlen of with. Right, this is how many characters I want to copy from with. Now you might ask, why didn't we just use strcopy? With strcopy you would have only 2 parameters and that would be done. The issue with strcopy is that it also copies the null terminator, right? So in here we really want to copy just this word, no null terminator after the s here, because if a null terminator would be right here, then the string would actually terminate at the word we want to replace with, which is not great, right? This is not really what we want. We actually want to not add a null terminator. So to not add a null terminator, what we have to do is to actually use memcopy or memmove. In this case, it would actually work the same way. But in this case, so here we could use memmove because it doesn't matter if it's overlapping memory. This guy, like substring source, is not overlapping in any way with our with string, but this guy is actually overlapping with this guy. And that's really all there is to it. If I try to run this code, let's try it, you'll notice we actually get an error saying that the stack around variable str was corrupted. That sounds pretty interesting, but it just says that we have basically a buffer overflow somewhere in our program. Well, it's pretty obvious what happened, right? This guy is of size 26, right? It's exactly as much as you can fit inside this string with all these characters. And what we want to do is replace this word with a larger word. And since there's not enough space here, it's actually corrupting memory from here onwards. What we have to do is to allocate enough memory for our string to be able to replace it. I'm going to say here allocate 100 characters, so we have enough space. If I run this now, you'll notice the apples are delicious, so that is before the call, and then the hamburgers are delicious, and that also now works. And of course, we can also replace with smaller words. We can say here, for example, cakes, right? This is just one character smaller than our apples character, but if we run this, it's of course going to work. Now you can really take this function and start using it in most of your programs, but I really want to optimize it a bit. As you have seen before I actually added this 100 here, the program would crash. Would it be nice to just kind of not do anything so it doesn't crash? We could actually check for it. What we could do is instead of passing it here 100, we can say let's say here size t source size, right? And we can actually check if there's enough space inside our source before really replacing it. So where do we do that? Well, right before we move anything in a memory, but after we check if there is that substring, right? So you can say here, if, what do we need to check? Well, if our source size is less, so if our source size is less than what? Less than our size of the source, or effective size, so the number of characters that are there, till the null terminator, minus or plus what? Well, plus the difference between the string that we want to replace with and the string that we are going to replace. So basically strlen of with minus strlen of substring. Okay, and if this is smaller, then we don't have enough space, right? Remember this guy? This is really that difference that we have talked about in the graphic here, right? strlen of with minus strlen of substring. So this is it. This is by how many characters the source string size changes. So it's either a positive number, that means that it's growing, or a negative number, that means it's shrinking. If it's shrinking, it's fine, but if it's growing, then that's a problem. So if that's the case, then simply, I don't know, let's printf buffer size is too small and \n and just return here. And one more thing to actually take into consideration is that source size here is the size, the memory size of our actual source. But in here, you'll notice that we only have strlens. And remember what I told you about strlens? They don't actually count the null terminator, but we always have to have a null terminator at the end. So I'm gonna also add 1 here because of that null terminator again. Now this is actually going to check properly, and in here, well, things are not going to work properly because I need to add another parameter, and I can say here 26, right? The string that we have here is 26 characters long, and if I do that and run it, you're going to notice that the buffer size is too small. Sure, you can probably print it on the std error stream, but that's also fine. But if I have here 100 and actually type in here 100, this is going to work perfectly. And of course, if there is, for example, 30 characters and 30 characters, remember the difference was exactly 4, there should be enough space, as you can see. But if we only have like 29 instead of 30, so this is almost enough space to actually replace the word, just one character missing. It should actually tell us that the buffer size is too small. So that's great. We have basically a finished product. One last thing I want to do is, remember I said that replace only the first occurrence, but what if I want to replace all of those occurrences? What should I do? What should I do in this case? Well, we can return something to the user, to the function that is calling this function, telling it either if it succeeded in replacing something or it did not succeed. By saying here, instead of void, we'll return a char pointer, for example. And in here we can say, we can return actually null if nothing happened. And then at the end here, I'm not really sure what we should return, but for something that is most useful, what you can return is really the string right after the replaced string. Maybe that could come in useful, but here you can decide. You can really just return the source if you wanted to. But I'm just going to return the substring source plus the strlen of our width. This is basically where our hamburgers word starts and plus its length. So right after our hamburgers word. In some cases this might be useful. You can also return source. As I said, it's fine. But now what I can do is actually check if what I got is either null or strlen. So for example, I can have multiple apples. So apples, and actually have enough space for them. So 100 characters. If I run it, oh wait, this is not enough space. I have to change this here as well. But as you can see now, I have enough space. And it only replaced the first apples. But what I can do is say, while this guy, please do replace. And if I run it, I'm gonna get the hamburgers are delicious. Hamburgers, as you can see. And it did replace every single one of them. Why? Because the while loop actually broke at the point where it got null here. So at one point it didn't find any apples in here, so it just kind of returned null. And then the while loop said, oh, okay, well, it's null, it's false, so I'm gonna get out of it. Otherwise, it's gonna continue because this string, this pointer is actually valid. And this is all there is to it. I hope you got something out of this video. This is actually much more complex than usual, so I hope you're still with me. I'm gonna leave the function down either in the description or to a pastebin link. You can check and you can actually use it if you want to. Do tell me if you do find some optimizations or improvements. I'm gonna continue updating that description in case I missed something crucial here. But for the most part, this is fairly safe. Not the safest, but fairly safe. And I hope you understood why we used everything here, right? Why we used memmove, why we used memcopy, and so on and so forth. Thank you so much for watching, and I hope to see you next time. Take care. Bye.